Alright, so we have seen that why can't we add copper directly into an acid? Why? Because it is unreactive, it will not show any reaction. In contrast, if we want to prepare sodium chloride, we cannot add sodium directly into an acid because it is a very reactive metal. Sodium even shows a violent reaction with water. So if you add sodium in acid, it is going to be very dangerous. So we cannot do that in lab. What we do instead, we add sodium hydroxide in an acid and in HCl in this case, so that we can obtain sodium chloride and water. This is a metal hydroxide, which is a soluble base or an alkali. We know that when alkalis they react with acid, they give us salt and water. Alright, so yes, sodium hydroxide it reacts with hydrochloric acid to give us sodium chloride and water. That is how you can obtain sodium chloride in lab. What are the steps for the preparation? Let's see. Number one, both reactants and products are liquid. Alright, so HCl is a liquid and sodium hydroxide is a liquid. We saw this case in ionic precipitation first, when both the starting materials were liquids, and but no solid is formed in this case. In ionic precipitation, the product was solid. We obtained an insoluble salt which was filtered off. But in this case, the product is also a liquid. So everything, the products are actually two liquids. We're starting with two liquid reactants, and what we get is a liquid product and another liquid product, and no gas is being given off. Alright, so how can we know that the reaction is completed? How do we know that both the reactants they have reacted with each other? Because no gas is being given off, no solid is being produced, there is no color change. So we use pH and indicator concept. We know that alkalis they have pH which is greater than 7 and acids have pH which is less than 7. So what we'll do is we'll add 25 centimeter cube of sodium hydroxide in a conical flask, and we use a pipette for the accuracy, and we'll add 2 to 3 drops of phenolphthalein, which is an indicator. And this indicator, it is pink in alkalis and it is colorless in acidic or neutral environments. So when we'll add phenolphthalein in sodium hydroxide, it will turn pink. Phenolphthalein will turn sodium hydroxide into pink color, which is an indication that its pH is greater than 7. That is what indicators do. So we now have a solution with phenolphthalein, solution of sodium hydroxide with phenolphthalein in it. So what we'll do is we'll add this acid, this HCl that we want to react with sodium hydroxide. We'll add this acid from a burette into that conical flask, and we'll add it drop by drop, and we'll keep swirling the flask carefully so that the acid does not spill out. And to help, this will help acid and alkali mix together. So what happens is, as acid is being added over here, now the pH will start to fall. The pH is greater than 7. Let's say the pH is 10, for example. As we are adding the acid, as acid is being added, it will lower the pH. pH will come to 8, and pH will 9, and then 8, and there will come a point when pH will be exactly 7. This is called the point of neutralization, when all the alkali it has been neutralized by the acid. Alright, so this is the exact point where this phenolphthalein will change color, because it is colorless in neutral and acidic conditions. By adding one drop of acid, all the solution will suddenly change from pink to colorless, because the pH is now 7, and at 7 pH phenolphthalein is colorless. Alright, so on adding one more drop, the solution changes from pink to colorless. This means all alkali has been used up. Now, if you go back to the equation, we had alkali in the flask and we were adding acid from the top. Alright, so when phenolphthalein changed color from pink to colorless, when phenolphthalein went from pink to colorless, this means that no more sodium hydroxide was left. And at that point we'll not add any more drop of acid. So that we can be sure that in our flask the alkali is gone and there is no acid as well. So what do we have in our flask? We have a solution of sodium chloride and we have water. Alright, because we were adding acid from the burette drop by drop and one drop was enough to change the color, and when that drop was added the pH became 7 and alkali is now completely gone. We stop adding HCl at that very moment. So now we are sure that in our flask we only have water and we only have sodium chloride. Now we want sodium chloride for it. You can guess how can we obtain that? We'll simply remove water and we'll get sodium chloride. So that is what happens. You add, the pH becomes 7, the solution becomes colorless, and you stop. No further drop of acid should be added at this point. The moment it turns colorless, the acid should be stopped. Alright, otherwise the solution will have HCl, obviously, which is not needed. Now solution only contains NaCl and water only. What we'll do is we'll read the burette reading, we'll see how much acid has been added, we'll read the burette from the scale and we'll note down that reading, and that is the amount of acid which is needed to neutralize that alkali. Alright, now we'll repeat the experiment with this exact same quantity of acid and we will not use indicator in this next experiment. Why? Because indicator is an impurity. We do not want indicators in our experiment. We only want the products to be NaCl plus H2O. We do not want phenolphthalein in it. We do not want any indicator. Indicator was only used to check how much acid is needed to neutralize that alkali. Alright, to neutralize that sodium hydroxide. So we'll repeat the experiment with that exact amount of acid that we have obtained from the first experiment, and then we'll heat the solution. We'll do the experiment up till here, and then we'll heat the solution of sodium chloride and water only. And in this solution we will not have any indicator because we have done this experiment again without indicator now. So this solution is heated and water evaporates and white crystals of sodium chloride will be left behind. Alright, so that is what we wanted. We wanted sodium chloride and we'll heat it so that we can remove water and sodium chloride is obtained. Let's see this one more time. So what you do is to prepare, in this case we are preparing potassium chloride, which is again a soluble salt. What you'll do is you'll start with, because it is a chloride, so you need an acid which has chloride ions in it. We'll start with hydrochloric acid, and because you need a potassium salt, so you need potassium hydroxide. Alright, so what will happen? Acid and alkali, it will react to form salt and water. Potassium will react with potassium ions will react with chloride ions to get potassium chloride, and this potassium chloride is obviously aqueous because it is a soluble salt, and you will obtain water. So all of these reactants and products, all the reactants and products are soluble. All the reactants and products are liquids. So yeah, what you'll do is you'll carry out titration. So this experiment that we do using an indicator and we neutralize an acid and alkali, this is titration. So what we'll do is we'll add 25 centimeter cube of potassium hydroxide. It must be a known quantity. You can do it 50 centimeter cubes, but it has to remain fixed and it has to be known. Alright, so in this case you're using 25 centimeter cubes of potassium hydroxide and 2 to 3 drops of phenolphthalein. Why? So that it turns pink. In alkali, potassium hydroxide is an alkali, phenolphthalein will turn pink when it is added in an alkali. So yes, and from this burette, what you're doing is you're adding acid drop by drop, and you see that the color, it starts to fade away. And fill the burette with hydrochloric acid and record the initial burette rating. That is done so that you know how you'll read the final burette rating at the end of the experiment, and you will see the difference, and so that you know how much acid is used. Slowly adding the acid into the conical flask and swirl until the indicator turns from pink to colorless. Record the volume of acid used, and you see that from here to here the indicator has changed color from pink and the solution is now colorless. Alright, so what you'll do is you'll record this reading of burette, how much of the acid is used. You'll see how much acid have you used, and what you'll do is you'll repeat the experiment now, but without using indicator this time, so that there are no impurities. Indicator acts as an impurity, remember. So yes, you'll again add the exact same amount of potassium hydroxide that you did in the previous experiment, and you will not add any indicator this time. You'll add the exact quantity of acid that you calculated in the previous experiment. You will swirl the acid and you'll shake it well. So yes, you will have sodium hydroxide and potassium hydroxide and water formed. So what you'll do is you'll evaporate it, water will be evaporated, and then you'll leave it for cooling. You'll filter the potassium hydroxide salt and you'll dry it, and crystals of potassium hydroxide will be obtained. I hope it is making sense. I'll see you in the next video.